Good morning, patient crowd. Between traffic and tech, there are always issues. It's like a theoretical easy. But good morning, and thank you all for being here today. Does this sound okay? The last day of winter. We celebrate the last day of winter. As a proud member of the Ridgefield Garden Club, it's my honor to continue the tradition of our hosting an annual Conservation Day program held here at the Ridgefield Library, which is once again generously co-sponsoring this event. Thanks go to Lucy Handley, the library's adult program coordinator, for helping me plan this program. And thanks to Roz Hooley and so many others in the Ridgefield Garden Club for taking me in and allowing me to become part of this great tradition. I've been a member for 2 years, and I can happily say that I have thoroughly enjoyed and benefited from all my time with the group. I am a passionate gardener and also a lover of trees, so here's Lucy. Just gave you a microphone. Well, I was getting feedback, so.
No, because he turned up the highest, but if you speak directly into
Okay,
people can
try that. I'm a passionate gardener and also a lover of trees. So it is for this reason that in planning this event, I maybe went out on a bit of a limb, unintended, in my search to find someone who could speak about our local forests. That search included a visit to the Yale Forest School website, where I came across Laura Green. A brief introduction. Laura is a New England native. She has a BA degree from Vassar College and a master's degree in forestry from the Yale School of the Environment, topped off by teaching experience at Southern Connecticut State University and the University of Connecticut. She's been a freelance consulting forester and botanist, and in addition to all this, Laura serves as a council member of the New England Botanical Society and is a plant conservation volunteer with the Native Plant Trust. Laura managed the Yale Forest Outreach Program, the Quiet Corner Initiative, which provides support for landowners and programming at the flagship Yale Myers Forest in northeastern Connecticut. Currently, Laura is the research and extension forester for the Yale Forest at the Yale School of the Environment, where she manages research programs for the Yale Forest 10,000 plus acres of forest land in Connecticut, Vermont, and New Hampshire. Phew, impressive credentials. Laura Green is a passionate and committed steward of our forests, and we're lucky to have her here today to speak about our changing forest, past, present, and future in Connecticut woods. Welcome, Laura.
Don, for that introduction. It really, having someone read out sort of your entire professional life at once really provides some perspective. But thank you all for your patience with us as I hit traffic on my way in. Had tech issues. I hope to make it worth your while. So I want to begin this morning actually sort of far away from the forest, with this document. Does anyone recognize this or have an idea of what it might be? From the Book of Kells. So an old document of some kind. It's written in a script that's hard for us to read. This is a 9th century document. It's called the Codex Nitriensis. It is documenting one of the Gospels, maybe the Book of Luke, or I can't remember, but I'm interested in it because it's a great example of what's called a palimpsest. The palimpsests are documents that were old manuscripts written on the pages of even earlier manuscripts. So in an effort to sort of conserve paper, reuse resources, people would wash away or scrape away previous writings and then write something new on top of it. So this is an example from the 9th century of a document that's written on top of pages from an earlier document back to the 6th or 7th century. There's sort of this ghostly element of the earlier text that's visible beneath the most recent writings. Our forests are very similar. The idea of a palimpsest is one of my favorite metaphors for a forest, because our landscapes have these multiple layers, and there are these earlier events that we can read and see the impacts of into the present, although they may be sort of ghostly or hard to know exactly what you're looking at if you don't have that context. So, in talking about the forests of Connecticut, it seems then wise to start with the past. And I will start with the very, very deep past. So if you'll indulge me for a few moments, we'll go back several 100 million years to the formation of Pangaea, the last of the great supercontinents before our present era. And much of Connecticut's bedrock was derived from this event, or even earlier than the formation of Pangaea. And I start here, though we're talking about forests, we're not talking about geology today, at least theoretically. This is the bedrock, literally and figuratively, for our modern forests. We have to go all the way down to the crust. So during the formation of Pangaea, we had the coming together of multiple land masses, what is sort of proto-North America, Africa, Eurasia, all of them colliding into one great continent. And in that event, we had the smooshing together of the landmass that was then eventually became what's now Connecticut. And that formed out of earlier continental land masses, some volcanic ocean island chains, and some of the ocean floor itself. And then 100 million years later, this is further complicated, this story, by the splitting apart of Pangaea, which created our big central rift valley in the middle of the state, and our trap rock ridges, sort of the origination of different sections of bedrock within our state. And I show this just to highlight at the bedrock, that foundational level, how much diversity there is in our state. So in this map here, the different colored polygons are bedrocks, different origins of bedrock. And then the brightly colored lines are ancient fault lines. So the pink line in the center there is that ancient Rift Valley fault line. So it's a place where the mantle was pulling apart and Pangaea was splitting up. That could have been the Atlantic, where the Atlantic Ocean was. Instead, the continent broke a little bit in a different place, a little farther east. But we can see that there are sort of 4 or 5 really large originations of different bedrock types within the state, sort of oriented on a north to south axis. And these different bedrock types then engender different qualities to the soils that are derived from them, which is important for all of you as folks who love to garden and are interested in plants, really of importance to anybody who's interested in plants, the qualities of our soil. But if we zoom in on Ridgefield specifically, we see a really thrilling sort of microcosm of the state overall, how much variation there is in our bedrock terrain. So this red line running through the middle of the town is called Cameron's Line. That's another ancient fault line, even older than the Connecticut Rift Valley fault line. And to the south of that, we have sort of ancient seafloor originating materials. And then to the north of that, that blue color is showing marble, so old kind of calcareous sea and lake creature skeletons that are then metamorphized into rock. And then the kind of gold color is an even older, the oldest rock that's found in the state of Connecticut. That is about 1 billion years old, twice as old as the surrounding bedrock. Really a dramatic picture. If we zoom in on the time scale to a time scale of millennia, so we're talking about millions of years. Now we're talking about thousands of years. The geological drama has not stopped. Not for a moment, well, for some moments, but not overall. And our landscape has been subject to multiple huge glaciation events over the last 100,000 years. When this happens during colder periods of long, extended colder climate, ice sheets from the north start to grow and eventually sort of descend down the continent until eventually the tide of the climate turns again, it becomes getting warmer, and those ice sheets melt out. But while they are growing, those glaciers essentially scrape clean the bedrock, and they pick up the soil that was there, it gets mixed around, and then when that glacier melts, it redeposits everything in a new sort of soil blanket over that bedrock landscape, which is what's shown in that diagram on the left side of the screen there. The white in that diagram is showing the bedrock topography, and then the green color is the soil that's been distributed on top by the glacier. So there are these really interesting sort of intersections between the bedrock material that is getting weathered into soil and is getting picked up by the glacier, gets moved a little bit, redeposited, mixed back up again. And the most recent glaciation event was about 20,000 years ago, and then retreating 15 to 12,000 years ago. Along with that, as that soil gets removed, we would imagine, all of the plants are removed as well. So we sort of restart the succession pathway. So this, on this side, on the left side, we have 4 boxes that are showing the arrival of plants as they were returning after this most recent glaciation event. And if you see here, the lines on those graphs are showing where those species were, what territory they occupied at different points in time. So the top left box is our white pine, and below it we've got our oak species, to the right of that our American beech. And we can see in all of these graphs that those lines show different trajectories for how species arrived on the landscape at different times. So there has never been kind of a mass migration of forest species as we know them today that arrived together and have stayed static through time. And we can see plants that will arrive, they'll do well in an area for a time, they'll become less competitive for some reason, maybe that's climatic, maybe that's interactions with other organisms, and then they move on. So this image, the animated image on the right of the screen is showing the movement of oak across our landscape over the course of several millennia. The green is showing the occupancy of oak on the landscape, and the lighter and darker colors are showing sort of what percentage of occupancy it has in that area. You can really see that it changes dramatically as that ice sheet retreats. Oak moves south, it moves west, and the how prevalent it is also changes over time. As we have plants moving in, we also have animals, which have significant interactions with plants. I include these in part just because they delight me, these ancient, charismatic megafauna. We have a ground of giant sloth on the left, a giant beaver on the right. You can imagine if we had huge sloths on the landscape today, that browse line, we think about sort of the browse line we're familiar with deer, and we can imagine what if that was, 15 feet instead, right? That would really change what that forest felt like, what strategies were successful for plants and able in order to kind of live alongside these organisms, how much sort of disturbance and destruction comes along with that. And then similarly, if you can imagine how thinking about the significance of the impact that beavers have on our landscape today in terms of hydrology and where water moves through the landscape and where it pools. If those ancient beavers were anything like our modern beavers, can you imagine the size of the dam that beaver could build? It would be really dramatic. So throughout all of time, there's been this interaction between our plants and the animals that are present. Sort of competitive factors and also facilitative factors, right? That sloth it's eating leaves, it's probably eating fruit as well, and moving seeds around. At the same time, in addition to many plants, many animals, we also have humans. So humans have been present on Connecticut's landscape essentially as soon as the glaciers retreated. So we have records of human habitation dating back at least 12,000 years. This map here is showing the locations of archaeological evidence from what's called the Paleo-Indian period, which is 10 to 12,000 years ago. And we can see that it's really kind of all over the state at that point. There were, within 10 to 12,000 years ago, people were really pretty widely dispersed on the landscape already. That was obviously at population levels that were much lower than today. Very different patterns of how people were living on the landscape and their relationships with the forest, but certainly present. The image here on the right side of the screen is showing a seasonal round, so sort of the importance of different organisms in the diet and life of people who are living in Connecticut in what's called the largely archaic period, which is about 6,000 years ago. And I include it largely to point out that these organisms are probably familiar to us today. So we've got bears, turkeys, white oak, wild rice, cattails. So these species have been present for a pretty long time, and people have been interacting with them in various ways. They've been important to people. These sort of specifics of lifeways obviously also change over time. So we know that habitation patterns in the past were not the same as they are today, and the extent of cleared land and what impact people were having on forests has also changed over time. So the extent to which people have burned the forest for millennia is sort of still an active area of conversation. If that was really widespread, if it was more localized, but we know folks may be more familiar from the West Coast that fire has long been a tool for landscape management that helps us keep fuel loads down in the West Coast, that helps encourage some species and discourage other species, and that's a tool that's been used very widely for thousands of years and all over the world. But the sort of footprint of that, if you have a much lower population density, is going to be different than it is today, with a very high population density, different technologies, and all of that. Also take a moment to talk a little bit about agriculture. You may be familiar with the Three Sisters or Milpa system of agriculture, corn, beans, and squash, which originated in Mesoamerica, then spread all over the place, widely adopted. What I think is less well known is that there are other sort of regionally developed suites of farming systems based on species that were endemic to those areas. So we have another agricultural complex, Eastern agricultural complex that originated in the Midwest, based on species that may be familiar to you as like weeds in your garden or in agricultural fields, like goosefoot, which is a chenopodium. Marsh elder, Iowa species, little barley, knotweeds, that's Polygonum erectum, I think. And then maygrass, which is a species of phalaris. You may know our very large common reed, phalaris. This is a smaller species. So there's a direct engagement with breeding native plants to serve particular agricultural purposes, and we see that all over the world. So bringing us a little farther into the present, take a moment and talk about this map. So this is a map that was drawn in 1930. It's based on a map from the 1700s. The person who made that map in the 1700s was depicting, they claimed, what sort of the social geography of Connecticut was in terms of indigenous village locations and groups, trails, at 1625, which is fairly early on in colonial settlement. And I say all of these caveats just to point out that this is many people's interpretation far removed from the time that it was happened, which is always helpful to remember whenever we're talking about things that happened a long time ago. But from that point, that European colonial settlement arrived in Eastern North America, very, very early on, introduced diseases that really ravaged, sort of decimated indigenous populations at the time, so that when European colonial settlers were arriving at new places, often they were seeing a landscape that had had a huge decimation of the indigenous population 50 or even 100 years before they were arriving. So we can think about the degree of kind of relationship that had existed for thousands of years. And then there's sort of this period of time where the population level is really low because of disease epidemics. How does that change the forests that colonial settlers, who are then starting to write things down, would be seeing when they arrived at those places. And this obviously is then followed by a more kind of intentional campaign of forced removal and dispossession of indigenous people from their land. So that is sort of where this graph here starts. I'm going to refer back to this graph a few times. This was from a 2010 report. I think it does just a beautiful job of summing up land use change in our region. So the different colored lines are showing the percent of forest cover in different New England states over a 400-year period from 1600 to about 2000. And at the bottom dashed line is showing the population in the region. So if you look at Connecticut as an interesting trajectory, it starts out as actually the most forested state in the region, based on this data at least. 95% forested in the year 1600. And then by the year 1850, we have less than 30% forest cover in the state. That's a massive change. The changes in the rest of the New England states are similarly dramatic. They're all on slightly different trajectories. We can see Maine, for example, is not cleared as much, and that clearing does not start in earnest until much later. These are sort of reflecting different historical patterns. But that period from sort of 1600 to 1850 represents a period of really intensive agricultural usage in our state and in the region broadly. So colonial occupancy and habitation on the land was accompanied by land clearing for agricultural fields, starting at a relatively small field if you were growing sort of subsistence crops for just your family, and then getting much, much larger as we started to look at more export-oriented or sort of market-oriented agricultural systems, like in parts of Connecticut, sheep were really important for a period of time. These are showing, these are from dioramas at the Fishery Museum at Harvard Forest. Has anyone been there or seen these? They're really wonderful, intricate dioramas, and they show sort of snapshots in time, imagining you're standing at a fixed point on the landscape and you're looking at it change around you over time. So this image on the left is estimating sort of what this landscape might have looked like in the year 1740. We can see a relatively small subsistence scale, sort of family farm plot. If we jump forward 100 years, we can see that the whole landscape around this little field has been deforested and is now like rolling pasture or hay fields. Forest products are also very valuable to people, and they always have been. And wood, in particular from large diameter trees, was very valuable in Europe because they had largely deforested their landscape of large diameter trees. So there's a great example of this is the King's Broad Arrow, which was a mark, this is an artist's rendition, but a mark that was used to designate very large pine trees, white pine trees, they're over 24 inches in diameter, that were claimed, they were reserved for the Crown, for the Royal Navy. And this was part of sort of original founding documents for like the Massachusetts colony in the 1690s. Particularly called out that these very large white pine trees were to be reserved for the Crown, and you could get in a lot of trouble if you cut them down for your own purposes. So there's sort of stories about like, oh, if you go into colonial houses, you'll find like a lot of pine boards that are 22 inches or 23 inches skirt the edges of this. That sort of colonial period also marks the introduction of a lot of new plants based on European colonial preferences and farming systems. For example, pasture grasses that are used for forage, and also just things that are beautiful, like lilacs are a great example. They've been planted in on this continent starting in like the 1700s. Both Thomas Jefferson and George Washington wrote about lilacs at various points. So people love plants, and they love the plants that they know. Other sort of forest products also drove sort of changes in land use and changes in land use, sort of forest clearing to produce things like firewood, structural timber for your houses, your barns, also furniture, fence posts, boxes, charcoal and bark for tanning. These are all sort of major resources that people were deriving from the forest kind of nearby them. These photos here are showing charcoaling mounds. So that image on the left is the creation of a charcoal mound. And these were areas of the landscape that were flattened, and then basically a huge mound of sticks and dirt was built on top of it. People, colliers, tended to the charcoaling fire for days and days and days, and then sold that charcoal. And this leaves visible evidence on the landscape even hundreds of years later. The image on the right there is a satellite elevation LiDAR map showing sort of changes in elevation on the landscape. And if you see those dark circles, those are flat areas from old charcoaling hearths. And you can still see this if you're out in the woods to some extent as well. It's very clear on the LiDAR, but you can also see it in the woods. So there are these sort of, again, these kind of ghostly writings, echoes of the past that are still visible today. So we have this long period of deforestation, conversion of land from primarily forest to primarily clear and agriculture. That then takes a steep turn in about 1850. That coincides with expansion into other parts of the country that have better farmland, changes in sort of economic structures and drivers, and we start to see forest regrowing. This means that most of the forest that we have on our landscape is not what's sometimes called primary forest or old growth forest, but is rather second or even third growth forest. So these are forests that grew up from largely old agricultural fields. This is a lovely diagram that shows that process. The image on the left being sort of an abandoned field. We start to get trees that seed into it. In our region, white pine and red cedar or eastern juniper are the most common trees that we see colonizing those fields after they're abandoned. So they can really tolerate that sort of like hot, sunny, dry conditions that you would find if you're trying to grow in the middle of an open field. They grow up over time. You can see in that image that's labeled C that we start to get other trees that are germinating underneath them and starting to sort of form an understory. And then D would be kind of a closed canopy forest that has pine at the very, very top, and then other kind of mixed species underneath it. The other significant sort of way that our forests originated were after big storm events. So I'll speak for a moment about climate and weather. This graph here on the right side of the screen, very busy and overwhelming. These are different sources of climatic data. So when we look at trying to recreate climate, there are things like ice cores, sort of deep ocean sediments that can help us to recreate climate at a global scale going back many thousands of years. When we want to look at what was happening at a more local scale, it's helpful to add in other sources of sort of records. So this, the many different lines that you're seeing on this graph are from things like pollen data, tree ring data. There's sort of lake sediment data, that's represented here. Marine sediment data. What I hope you can see is that the time is on the bottom axis from 1,000 years BCE to 2000, so 3,000 year time span. And for most of that, there's sort of an up and down variation in temperature. And then in about 1850 or so, we get a dramatic uptick. So that is anthropogenic climate change, so human-derived change in the climate that we're seeing more recently. I also think this is useful to point out and to look at this very long time scale, because you'll see that there's a blue line there. That is from what's called the Little Ice Age, which was a period of time where we had much cooler temperatures than was sort of average. And that coincided, it's about 1400 to about 1800, it really coincided with that early colonial period, which sort of adds another layer to the complexity of why were forests the way that they were when European colonists arrived here, and why are they different now? Largely, in the absence of humans, our forests are regenerated. So canopy trees get blown over, new trees get come up in their place as a result of large storm events. So hurricanes and tropical cyclones that don't maybe quite rise to the level of a hurricane are a long-standing major disturbance event in our forests. They knock over small areas to very large areas of the forest at the time, and where those canopy trees have been removed, new trees can grow up. So the most recent really large hurricane event was out of the memory of most all of us at this point. It was the hurricane of 1938. These are photos showing the effects of that hurricane in Connecticut. The photo on the left is on Huntington Street in Haven, if anyone is familiar with that area, showing just basically all of the street trees have blown over. And then the image on the right is from a more rural area. That photo is taken here somewhere near Willimantic. Again, showing just this total destruction of the forest. Parts of Connecticut were spared from this. The western part of the state was less impacted overall. But this is a huge event that sort of restarted a lot of our forests. Interestingly, at least so far, the signature of frequency of these really severe storms does not seem to be really evidently tied to climate change, at least in our region. There's not been a clear signal of increasing or decreasing hurricane or tropical cyclone frequency. The diagram on this is showing the frequency of hurricanes or large storm events in New England specifically from the mid-1700s to the present day. And we can see that there is kind of an up and down variation over time, but there has not been like a dramatic or clear sort of increase in the frequency of these storms. Okay, why did I spend so much time talking about all this? Essentially, what I'd like you to take away from this is that the past really significantly shapes our expectations. It shapes what we see today, and what we see today and what we're familiar with largely informs what we expect to see or think we should see for the future. And there's a name for this in ecology. It's called shifting baseline syndrome. Essentially, the idea is that what we think is normal or natural is largely based on the experience within our lifetime, maybe a generation or two generations before us. Sort of what is the span of human memory? And what was normal or natural appearing 20 generations ago may be totally unfamiliar. Cast that back 200 generations ago, right? Things get more and more dramatically different over time. This graph here is showing forest change in Japan, but I think it's a nice illumination of this. The different colors are representing the proportion of the forest that is old growth, or I think either primarily naturally regenerated without human intervention. The middle green is from a coppice, which is a silvicultural method of creating sort of small diameter growth of trees. And then the lighter green is directly human regenerated and more intensively managed forests. And then that very lightest green color is forests that were planted entirely by humans. And we can see this is from 1400 to the present, that the proportions of each of those are really different. And if you look at that on a generational time scale, which is the lower of the two graphs, if you went back one generation, those proportions are really different. If you went back 20 generations, they're really, really different. And thinking just about the impact that this has on what we expect out of our landscape. So an example from here in Ridgefield, this is from a really awesome tool through Yukon, which is showing neighborhood change. On the left, we have an aerial image from 1934, on the right from 2019, and we can see in the 1934 image that there are like large swaths of agricultural land. Today, there is essentially none of that. We have largely urban, suburban development, and then regenerated forest land. So, taking all this into account, what are the layers that make up our forest palimpsest? One is continental scale geology, bedrock geology. There are these glaciation events, sort of large scale, thousands of years changes in climate. That then informs the soils that we have and the landforms that we have. Add on another layer of plant and animal migration, the climate and the weather, and then many millennia of human habitation and use of our landscape. And that brings us to the present. So we'll return again to this graph here. We've talked about the period of deforestation, that was then followed by a period of reforestation. And we'll return again to this lovely diagram that shows the transition of from an agricultural field to closed canopy forest. But I will say that forest development did not stop here in New England. These are that same dioramas that I had photos of earlier. The image here is showing what happened after, after we had this lovely closed canopy pine forest. It so happens that in the 1910s, we had a lot of need for boxes to ship things in, and cardboard hadn't been invented yet. And so much of those pine forests that had just regenerated on our old fields, the pine was cut out, used to make boxes, and that left hardwood, those smaller hardwood species, so broadleaf deciduous species that were growing underneath the pine trees. They were often cut as well, but they were able to resprout in the 1940s or 50s. What you had is this bottom image where we've got a new, what is now all kind of hardwood dominated stand on the landscape. These kind of complex factors that over 5 years or 10 years, it may not look like a lot is happening, but if you look back over the scale of several decades or centuries, the change is really dramatic. So that brings us through this period of reforestation, right? That is still a forest. We haven't had a conversion of the land use. It was a forest and it's a different kind of forest, but it's still a forest. What has happened though is that we've actually entered a new period of deforestation, and that is really driven by urban and suburban development. So these are images from a paper that was looking at forest loss and land cover change over time using satellite imagery, trying to look at what are the drivers of this, what are the patterns that we see. This study found that there has been a loss of about 1,300 square miles of forest in New England between 1985 and 2017. That is larger than the area of Rhode Island, to give you a sense of scale. That rate of that change has not been static. It was highest in that sort of 1990 to 2000 period. It's been slower since then. And the overall trend is that areas that were more developed, closer to roads, had a higher population in the 1980s, are more likely to have lost forest when we get to 2000 or 2010. So in addition to a change in the amount of forest on our landscape, we've also had changes in the makeup of that forest. So these are two images looking at the composition of the forest. I can talk more about the methods here, but I'm going to skip it for time, but they're really interesting. And we can see, you see those different colors are each pie charts for a specific location, showing the composition of the canopy of the forest in that location. And you can see just the change of the different colors is telling you that there's a change in the dominant species composition of our forests from 1700 to the present day. Zooming in on Connecticut in particular, I want to highlight these sort of yellowy and orangey colors represent chestnuts, oaks, and hickories. And if you see that red color is representing maple, that's mostly red maple. And you can see that that has been sort of a major shift in our forest in the last 400 years, from being more dominated by oaks, hickories, chestnut, to having a much larger composition of maple in the forest. Why? What's going on? Disease is part of it, for sure. So one of the issues is that different species require different conditions to thrive. So in young forest, for gray birch does really well, might be super prolific. You think like, oh, that's the one to watch. But it does not do well when it gets overtopped. So over time, we lose gray birch entirely from the forest as other trees, which keep growing and get taller, start out maybe more slowly, but then take off, and they outcompete that birch. They block its light, and it dies back entirely. There are also differences, even within a single genus, in the requirements and the niches of particular species. So within our oaks, we've got bare oak, which is a low, kind of shrubby growing plant that really only thrives in dry sites like ridges and sand plains. In contrast, pin oak, still an oak, likes to live in floodplain forests, and then is also planted really widely as a street tree. Disease is also very important here, particularly when it comes to chestnut. Previously, chestnuts made a really dramatic proportion of our forests across the eastern United States, 30% plus of the canopy trees. The introduction of chestnut blight in the early 1900s has changed that dramatically. It sounds like folks are familiar with that, so I will not belabor it. At the same time, we've also seen the expansion of species sort of beyond what their range was previously. We see this with American holly. Really interestingly, depending on who you ask, American holly may or may not be native to Connecticut, but it's certainly here now and seems to be spreading, particularly along the shoreline. I think there's a question here about how much of this is because we plant American holly because it's lovely and it's nice in gardens and it's native-ish, and how much of this is because birds are eating those seeds and they're pooping them out somewhere new, and that's sort of a natural range expansion. We don't know really what is the driver for that. We also have changes in the tools that we use to manage our landscape. So fire has been important at various points in the past to a varying degree. It was then excluded from our landscape for a long time. It can be used as a tool that really promotes desired species that have particular requirements, like our oaks or pitch pine, for example. The loss of oaks in our forests is attributed in part to what's called mesification of our forests, which is essentially a trend towards species that are more moisture loving over time. That creates conditions that are darker, they're damper, and they're cooler, sort of in the forest, which then perpetuates those species persisting on the landscape. Forest pests and pathogens play a considerable role, particularly at present. There have been repeated introductions of new pests. Often this happens unintentionally, sometimes on nursery stock, sometimes on shipping material. And these are insects that are usually native somewhere that has a similar flora to our own. And that goes way back to that continental geography timescales. You'll remember that North America and Eurasia used to be a lot closer to each other. So there are parts of Europe and Eastern Asia that have really similar climates and sort of deep time history to our own, have very similar floras. And insect pests that are adapted to those species that can eat our versions of those species. So hemlock woolly dalgid, which is from Japan, adapted to living with Japanese hemlock trees, comes here, does perfectly fine eating our hemlock trees, but there isn't the same kind of competitive dynamic